If you look at a typical home through a thermal lens in winter, you don't see a solid shelter. You see a massive radiator. Heat continuously bleeds out through the roof, the walls, and poorly sealed windows. Every hour that energy escapes, you are paying to replace it, and power plants are burning fuel just to keep pace with the loss. This structural flaw forces us to rely entirely on an external, vulnerable grid. If a winter storm severs that power supply, the house loses its ability to function and keep you warm almost immediately. A net zero home approaches this physics problem backward. The objective is to design a structure that generates enough of its own power over the course of a year that the utility meter essentially spins in reverse. This diagram illustrates the core rule of net zero. It's a strict thermodynamic equation. You are balancing energy consumed against energy produced. You cannot simply slap solar panels on the roof of a leaky house to balance the scale. Before you attempt to generate a single watt of your own power, you have to shrink the consumption side of that scale. Without driving demand down first, true energy independence is mathematically impossible. To eliminate that demand, builders establish what is called a continuous thermal envelope. This involves wrapping the entire structure, from the concrete foundation straight up to the roofline, in dense insulation, closing off every gap where heat normally bypasses the walls. Once insulated, the structure is obsessively sealed against air leaks. Standard windows are replaced with heavy triple-pane glazing. The thermal energy inside the living space is now securely trapped. Passive solar design exploits the sun's natural trajectory for free heat. In winter, the low sun streams deep through south-facing windows, warming the floors. In summer, as the sun shifts higher, roof overhangs physically block those rays, keeping the house cool. But sealing a house this tightly introduces an immediate danger. Human breath, cooking, and daily living cause moisture and stale air to build up fast. You have to ventilate the interior, but opening a window ruins all the thermal engineering. This schematic outlines the mechanical lung of the house, the Energy Recovery Ventilator, or ERV. It exhausts the stale indoor air while transferring its heat directly to the incoming cold, fresh outdoor air, completely without mixing the two streams. By combining passive solar geometry with an airtight, mechanically ventilated envelope, a home requires a tiny fraction of the energy a standard build needs. The consumption side of our equation is finally small enough to solve. With the structural demand minimized, we look at the other side of the scale. The production target we need to hit is now incredibly low. Hitting that target requires removing gas lines and combustion entirely from the property. Every system, from the stove to the water heater, transitions to ultra-efficient electricity. The electric heat pump is the critical tool for this transition. Instead of burning fuel, a heat pump operates like a reversible refrigerator, moving existing ambient thermal energy from the outside air directly into your home. The final architectural step is generating the electricity to run those efficient systems. We do this by adding a solar photovoltaic array to the roof. Because the structure is already hyper-efficient, you don't need a sprawling, expensive commercial solar array. The panels are engineered specifically to match the home's newly shrunken energy profile. This line graph maps that balance over a full year. In summer, the panels produce surplus power. In winter, production dips while heating demand rises. Over a 12-month cycle, local production and localized consumption perfectly equal each other. By balancing this equation, you are left with an autonomous micro-power plant that happens to look like a house. If the local utility grid fails during a storm, the poorly sealed houses down the street will freeze in hours. This structure stays warm, ventilated, and powered indefinitely. Now scale those engineering principles. Look at an entire neighborhood built on this exact same thermodynamic foundation. Instead of hundreds of individual structures constantly draining resources from a central power plant, you have a network of independent nodes producing their own power, stabilizing each other, and pushing clean surplus energy back into the city. By solving the consumption and production equation, the architecture itself becomes a utility. The home operates as an active technology that sustains our energy grid rather than a passive box that depletes it.